Soil pH is a measure of the acidity or alkalinity of the soil, indicating the concentration of hydrogen ions in the soil solution. It is an essential factor that affects the availability of nutrients to plants and influences their growth and development. The pH scale ranges from 0 to 14, with 7 being neutral. Values below 7 are considered acidic, while values above 7 are alkaline. Different plants have specific preferences for soil pH levels, and understanding these preferences is crucial for successful gardening or farming. Here's a breakdown of plant preferences for different pH ranges. 1. Acidic soil, pH below 7. Plants that prefer acidic soil include blueberries. These acid-loving plants thrive in a pH range of 4.0 to 5.0. Azaleas and rhododendrons. These flowering shrubs prefer a pH range of 4.5 to 6.0. Hydrangeas. Different varieties of hydrangeas thrive in various pH ranges, but generally, they prefer acidic soil between 5.2 and 6.2. Pine trees. Most pine trees prefer slightly acidic soil with a pH range of 5.0 to 6.5. Ferns. Many fern species prefer slightly acidic to neutral soil conditions. Many orchids. Orchids usually grow well in slightly acidic conditions, around 5.5 to 6.5. 2. Neutral soil, pH around 7. Many common garden plants thrive in neutral soil conditions. Examples include tomatoes. Tomatoes generally prefer soil pH between 6.0 and 7.0. Beans. Most bean varieties grow well in soil with a pH range of 6.0 to 7.0. Lettuce. Lettuce prefers a slightly acidic to neutral soil, with a pH range of 6.0 to 7.0. Herbs, such as basil, parsley, and mint. Most herbs grow well in a pH range of 6.0 to 7.0. Roses. Roses typically prefer slightly acidic to neutral soil conditions. 3. Alkaline soil, pH above 7. Some plants are well suited to alkaline soil conditions. Lavender. Lavender thrives in alkaline soil with a pH range of 6.5 to 7.5. Cacti and succulents. These plants can tolerate slightly alkaline conditions, typically with a pH range of 6.0 to 7.5. Lilacs. Lilacs prefer slightly alkaline to neutral soil conditions, with a pH range of 6.5 to 7.5. Yarrow. Yarrow is a perennial herb that can tolerate alkaline soil with a pH range of 6.0 to 7.5. Dianthus. Dianthus plants prefer alkaline soil, generally with a pH range of 6.0 to 7.5. It's important to note that while plants have preferred pH ranges, they can often tolerate slight deviations from their optimal conditions. However, extreme pH levels can hinder nutrient availability, leading to nutrient deficiencies or toxicities and impacting plant health. Cation exchange rate, also known as cation exchange capacity, CEC, is an important property of soil that influences its ability to retain and supply essential plant nutrients. It measures the soil's capacity to retain and exchange positively charged ions, known as cations, such as calcium, Ca2+, magnesium, Mg2+, potassium, K+, and others. The cation exchange process occurs on the surfaces of soil particles, particularly clay and organic matter, which have negatively charged sites called exchange sites. These exchange sites attract and hold cations through electrostatic forces, preventing them from being leached away with water. When plants require certain cations for growth, they can exchange hydrogen ions, H+, from their roots with the cations attached to the soil particles, effectively taking up the nutrients. The cation exchange rate or CEC is a measure of the soil's ability to retain and exchange cations. It is expressed in terms of milliequivalents per 100 grams of soil, milliequivalent/100 g. Soils with a higher CEC can hold more cations and, therefore, have a greater nutrient holding capacity. The cation exchange rate is influenced by several factors. 1. Soil texture, clay soils generally have a higher CEC compared to sandy soils because clays have more surface area and higher clay content, providing more exchange sites for cations. 2. Organic matter content. Soils rich in organic matter tend to have a higher CEC due to the presence of humus, which has numerous negatively charged sites capable of attracting and holding cations. 3. Soil pH. Soil pH affects the cation exchange rate as it influences the charge on the soil particles. In acidic soils, there is an abundance of hydrogen ions, which can displace cations from exchange sites, resulting in lower CEC. In alkaline soils, the presence of hydroxide ions can also affect the cation exchange rate. The cation exchange rate plays a crucial role in nutrient availability to plants. Soils with higher CEC can retain more nutrients, reducing the risk of nutrient leaching and making them more fertile. However, it's important to note that CEC alone does not indicate nutrient availability or soil fertility. Other factors such as nutrient balance, soil pH, and soil organic matter content also play significant roles. Understanding the cation exchange rate of a soil is valuable in agricultural and horticultural practices. It helps guide nutrient management strategies, such as determining appropriate fertilizer application rates, understanding nutrient deficiencies or excesses, and assessing the need for soil amendments to optimize plant growth. To determine the soil pH and the cation exchange rate of a soil in your garden, you can use a pH testing kit, pH meter for a general idea of soil pH, or send a soil sample to a local agricultural extension service or laboratory for analysis. Adjusting soil pH can be achieved by adding amendments such as lime to raise pH or elemental sulfur to lower pH. It's always advisable to follow recommended guidelines and consult local experts for specific soil and plant requirements in your region.